So today we're going to look at inverse, what's called inverse functions. Inverse, okay? So you might have done this in Math 3, you might not have. Inverse functions are when we swap x and y. X and y switch spots, okay? Everything, so all the domains, because right, domain means x. When I talk about domain, I mean the x-axis. When I talk about the range, I mean the y-axis. They're swapped, okay? So what does that look like? Well, the graphs are symmetric. If you were to graph one and then graph its inverse, they would be symmetric across y equals x. That's not really the important things. This stuff here, these bullet points, these properties, they're not really important for this class, but I always get the question, what's an inverse? That's why I put these on here, okay? So inverses, for a function to have an inverse, the degree has to be negative, or sorry, the degree has to be odd, okay? That's this bullet point here. What's called one-to-one. It has to pass, you know, the horizontal line test you guys did back in junior high, Math 1. Well, there's a horizontal line test. And for it to have an inverse, it has to pass that. So the easy way to tell is the degree has to be odd. This degree here is 1 because it's x to the first power. That's the highest. So it has to be, so like we can't do any x squareds, x to the fourths, x. If that's the highest power, then it won't have an inverse. Okay? Yeah, so there, we'll deal with it. There is okay because it's x to the first. I know it's a square root, but we'll deal with it. Monotonic, always increasing or always decreasing. So the only functions that have inverses are the ones that are always increasing or vice versa, always decreasing. So quadratic, like for example, quadratic. When I graph a quadratic, it's either going to look like that or that. X squared, when x squared is the highest power, right? That's what it's going to look like. Those guys are both increasing and decreasing, right? Decreasing and then increasing, and then vice versa. Increasing, then. So for it to have a inverse, it has to always be increasing or always be decreasing. So an example of that is linear. Linear functions are always either increasing or they're always decreasing. Lines have to either go up or go down, or not increase at all, right? They're constant. Another one is cubics. Cubics look like this. So cubics are either always going up, they slow down, but then they're always increasing, or they're always decreasing. They slow down, but then they're always decreasing, okay? So let's see, and then the last one, the inverse function of f of x. So if you see this little notation here, that means the inverse. That little notation there to the negative 1 power, it's an inverse, okay? So how do we find inverses? Again, you might have done this in Math 3. This is not, this first example, that's why the example doesn't even have a number 1. It's like a pre-example. These two examples aren't something you're going to see in this class. We're only dealing with derivatives, but I didn't want to go into that until you knew what an inverse was. So if we want to find an inverse, the first thing we're going to do is swap x and y. So f of x is really just y. So the first thing you would do to find an inverse is switch x and y. So x goes over here, y goes over here. And then you solve for y. Subtract 2 from both sides. Divide by 6. That's the inverse. So That guy and that guy are inverses of each other, what we call inverses. They're both straight lines, but they're inverses of each other.
So to find the inverse, we just do that, and then we do the derivative after.
Mm-hmm. And then find the inverse of this guy. The inverse of this guy, you're going to do the exact same thing. Y equals x minus 5 square root plus 3. First thing you always do to find an inverse is flip the x and the y. And then you solve for y. So this part I'm going over a little fast because they're not going to ask you to do this. They're never going to ask you to find the inverse. I'm just doing a little bit of background on why inverses are the way they are. So I'm going a little fast here. And then to get rid of the root, we got to square it because it's a square root. And then you're going to add 5 to both sides. That gets rid of that y, so now you have y by itself. So I have x minus 3 squared plus 5. Okay, so this guy and this guy are the total opposites of each other. You look at them, they are opposites. One has a square root. What's the opposite of a square root?
Squared.
It's got a squared. This one has a plus 5. What's the opposite of a plus 5?
Minus 5.
Right? This one has a plus 3. What's the opposite of a plus 3?
Minus 3.
It's completely opposite. Inverse is just an opposite. Okay? So that's where inverses come from. That's how to find inverses. Again, that's more of a math 3 thing. What we're going to do is find the derivatives of those guys. So what they're going to do is they're going to say, hey, find the derivative, not of this guy, of its inverse. That's what they're going to say today. Okay? So there's a couple different ways to do it. Same thing. They're going to give you this guy, and they're going to say, find the derivative, not of this guy, but of its inverse. That's what they're asking us to do today. That's why it's different than that. Okay, so how do you do it? What is the magic formula for it? These guys right here. Okay, so I highlighted it in green and yellow because which one do we use? Well, it depends on what they give you. Okay, so if they give you tables, sometimes they'll give you tables, x and y tables. If they do that, use the yellow. If they give you equations instead, use the green. Okay? So I'm not going to use the green steps if they give me a table. I'm not going to use the formula in yellow if they give me an equation. Okay? That's how to do it. So this is your steps on how to find inverse derivatives of an inverse. Okay? So we'll use those steps, the ones that say steps, we'll use those when they give us an equation. Or we'll use this formula kind of thing when they give us a table. Okay? So we'll go through. We're going to go through on the back page. We're going to do an example, and we'll decide which one we need to use, green or yellow. So find the derivative of the inverse functions. Find a derivative of the inverse functions. And then it says f of x, if f of x equals x cubed plus 4x plus 2, we got to find, see here's the notation here, the inverse's derivative at -3. So they want me to find the inverse, find the derivative of the inverse, and then plug in -3. Okay? Okay, so which one is this? Did they give us a table or did they give us an equation for this guy?
Equation.
This is an equation, right? F of x equals. So how are we going to solve it? We're going to use these steps here. Okay? This one they didn't use G. I don't think they used G. I think they just used F. Okay, so Set f of x equal to a. Set f of x equal to a. That's the first step. Well, f of x I know. I know what f of x is. They tell me, right? X cubed plus 4x plus 2. So that's step one. We're going to set that equal to a, the a term. What is the a term? -3. Yep. That is the a term. That is the term in parentheses. Okay? That's the first step. Second step. Oh, first step, we didn't finish it. And solve for x. Okay, so what what you got to do in your head is figure out what number, when I cube it and multiply it times 4, then add 2, will I get -3? Do some mental math. What number, when I cube it and then multiply it times 4 and then add 2, will I get -3 as an answer? I'll give you a hint, it's a whole number.
-2?
So let's see, -2 cubed. So if I were to do -2 cubed, that's -8, right? And then if I were to do -2 in here, that's -8 plus 2. That would be 2. Close.
So -1?
Let's say -1. What's -1 times -1 times -1? -1. What's -1 times 4? -4 plus 2
equals -3.
There you go, you got it. Okay? It's always going to be a whole number. Might be positive, might be negative, but that's step one. Okay? Step two. Find f prime of x. So what does that mean? Find f prime of x. Find the derivative of f. F is right there. So the derivative, I'm just going to use the power rule. 3x squared plus 4. That's step two. Step three. Find f prime of your answer from step one. So whatever you got for x, you're going to plug it in those parentheses there. So f prime, and what did we get from step one?
-1.
Mm-hmm. F prime of -1. So I need to plug it in, right? So I'm going to plug it in to f prime. So what is this? 3 times 1 plus 4. 7. So f prime of -1 equals 7. That was step 3. Step 4. Flip it. What do you get when you flip it?
1/7.
Mm-hmm. So that's our answer. 1/7. And that's what they ask us to find. That's what the notation there is exactly what they asked us to find. So that's why I put it there to show that's my answer. Now, is that the only way to do it? No. But that's the way I found is simplest to do. Those 3 steps, 4 steps, whatever it is, I found it is simplest to do those, to do that method. That's not the only way, but like I said, over the years, I've found kind of the simplest way. All right, so let's do letter B now. So are we going to use the yellow, or are we going to use the green again for letter B? The green again, right? There's no table. They've given us an equation. Okay. So step one. What was step one again?
Just write the equation and set it equal to the A term.
Write the equation and set it equal to the A term. The A term in this case?
1.
Positive 1. Mental math time.
2.
So yeah, so what I'm trying to do in my head is figure out what number when I cube it and subtract 7 and take the square root is going to equal 1. And the answer is 2. Because when you cube 8, or cube 2, you get 8. 8 minus 1 is 1. The square root of 1 is 1. That's part A. Or sorry, step 1. Step 2. Find f prime of x. So f of x is this guy. I need to find the derivative. So what am I going to do to find the derivative?
Use the chain rule.
I'm going to have to use the chain rule after I rewrite it, because I don't want a power, or I don't want a root, I want a power. So you're going to go x to the third minus 7 to the positive 1/2. Okay, so the derivative. So if it's the chain rule, there's an outside and there's an inside. So I'm going to find the derivative of the outside first. 1/2 x cubed minus 7, subtract a power, I get negative 1/2, times the derivative of the yellow, which is 3x squared. Okay. I'm just going to leave it like that for right now. I'm going to come back to it in my next steps, but for right now, I'm good. Step 3, what did step 3 say to do?
Plug in the x term you got into the original equation.
Plug in the answer I got from number 1 into that derivative. So anywhere there's an x, I'm going to plug in the answer I got from step 1. So in other words, I need to figure out what that is. Okay. 1/2 parentheses 2 cubed minus 7 to the negative 1/2 times 3 2 squared. PEMDAS, order of operations, 1/2, parentheses first. 2 cubed is 8. 8 minus 7, 1. 2 squared is 2 squared is 4 times 3, 12. So I still have exponents. So what is 1 to the negative 1/2 power? 1. Yeah, 1 to any power. Positive, negative, fraction, whole number. 1 to any power is always just going to be positive 1. So you got 1/2 times 1 times 12.
Use the 12 over 2.
12 over 2, or just 6, right? 12 over 2 is the same as 6. Because 1 times 1/2 is 1/2 times 12 is 6. Last step. Flip the answer you just got. So if I flip 6, what do I get?
1 over 6.
1 over 6. So g prime of 1 is what they were originally asking, is 1 over 6. I'll give you a hint. Most of the ones you do this way, you're going to get fractions as answers. It's going to be 1 over something. It might be positive, might be negative, but most of the ones that you do this way, like we did A and B, you're going to get fractions as answers. Okay? All right. That's equations. Let's go to the next one. The next one is table. We got a table one. We haven't done a table one yet. So the table is an x and a y chart, right? F of x is just y. And then f prime is the derivative of f. Okay? So we got to figure out this guy here. So this time we're not going to use the green. We are going to use the yellow part that we haven't used yet. The shorter part. We need to build this guy. That's what I need to build. Okay? So, so the first thing I'm going to do is I'm going to build that guy. So I'm going to rewrite it. Okay, so what it said to do was this. It said f to the negative 1 prime of x. I'm just rewriting it literally from the first page to this page. And then you're going to do 1 f prime that. Okay, this is for tables, this is what we're going to do. Except for this guy, they said this. They said g of x is the same thing as this guy over here. So instead of that, instead of that, they said this. Write this down. G prime of x equals that fraction there. So just the notations. Because they said g of x is the same thing as the inverse of f. So what's the first thing you think I'm going to do?
Plug in 6.
Plug in 6. Everywhere there's an x, plug in 6. That's my a value. Okay, that's the first step. Now start solving this guy. Well, we start on the inside. So the first thing I got to do is find that guy. What does that mean? What does the purple mean? Pink, purple.
The inverse.
It's the inverse when x is 6. So the inverse when x is 6. So in other words, not when x is 6, when y is 6, because the inverse flips them. So I got to go to my table.
So negative 5.
So they want to know, that's not x, this is y now, because it's inverse. F of 6 means x. F inverse, this is where people get thrown off. This is a big, big one, because they don't know what this means. So where is y equal to 6? Negative 3, right? So this guy is equal to negative 3. Okay, so this meant when y equals 6, x equals what? That's what that meant. When x equals 6, when y equals 6, sorry, x equals what? Negative 3. Okay. F prime of negative 3.
Negative
Negative 1.
So it's equal to -1?
So it's equal to 1 over -1, which is the same thing as
-1.
-1. Okay. I'm going to give you another one like that. Not yet, but I'll give you another one like that in a second. All right. Actually, no, let me do it right now. Find the spot. Let's do C2, like C.2, C.2. I'm going to find, I got another one I want you to do like that. Okay. C.2. Okay. Let's see. Okay, so here we go. So this is what I want you to do. I want you to find f -1 prime of 4. And I'm going to give you the table. Okay, so here's the table. There you go. The ones with the table are usually the more difficult ones, and they're usually the ones that you'll see the most because of that.
They seem easier, to be honest.
Good. Okay. So what is f of inverse, the derivative of the inverse at 4? The derivative of the inverse at 4. I'll give you a hint. The answer is going to be a fraction. It's going to be -1/10. So what's the first step I got to do if I'm doing this?
Replace the x.
Personalize it so that it's what you're trying to solve. So it's 4, right? 1. 4. First step. Second step. In math, we work from the inside. What does that mean here?
Wherever f of x is equal to 4. So 2.
Y is 4. What is x? Positive 2, right? If 4 is y, what is x going to be? Well, 1 over f prime of 2. If y is 4, x has to be 2. That's what it's asking. F of x or y, because f of x and y are the same thing. Then f prime of 2 is negative 10. Okay. All right. All right. So let's go to that one. Let's go back to D now. I don't think we're going to get to the trig stuff. We'll get that to tomorrow, but I want to do, if we have some time, I'll give you another problem like this. Okay? The function f of x is defined by f of x at the point 1 comma negative 6 is on the graph f. If g of x is the inverse, what is the value of g prime of negative 6? So go back to here. Which one is this going to be, a yellow or a green? It's going to be a green. It's going to be a green because it gives us an equation that said f of x is this. Okay. Okay. So what does step 1 say to do?
Set it equal to the number.
Set f of x equal to the number, good.
Would it be negative 6?
Negative 6. Negative 6. Because this is the a term, right? We set it equal to the a term. That's this guy here. It's kind of reversed. We're used to plugging in x, right? But since this is the since this is the inverse, it's actually y. That's how this is a little different. So you're going to plug this guy in. Or sorry, not plug it in. You're going to set it equal to negative 6. Mental math.
1.
Yeah, it's going to be positive 1, yeah. It's going to be positive 1 because if I put in positive 1 here and here, it gives me negative 6. So x equals positive 1. Step 2. What was step 2?
Solve the derivative or figure out the derivative?
Find f prime of x. Well, you're just going to use, you don't have to use the chain rule or quotient rule or product rule for this. It's just the power rule. Step 3.
Plugging the x term into the derivative.
Put 1 in here. We get negative 7. Step 4, flip it.
Negative 1/7.
G prime of negative 6 equals 1/7.
What was the point of including the point?
Say what?
What was the purpose of including the point?
That's a good question. It was just, we didn't need it, right? Yeah, why did they? So this one, it was different because they included the point, right? What was that? We didn't need it on this one. Yeah, it was just extra information that we didn't need. Okay, so we're not going to go into the trig stuff yet because it's not hard, but it's going to take longer than 10 minutes for me to explain that. So I'm going to give you some practice on this. So here's the thing. Inverses aren't hard. Derivatives of inverses are not hard. They're just different because we're looking for y instead of x. It's just reverse on everything you've done up to this point. So that's the thing about these guys. It's kind of backwards. Okay? So f of x, I'm not going to give you the whole thing. I'm just going to say f of x equals negative x cubed plus x squared minus 4x f negative 1 of x is equal to g of x. So g of x is the inverse. And then the question says g prime of negative 4 equals what? This will be the last one we do today. So step one's usually the hardest because it's mental math. You got a picture in your head. Negative what cubed plus what squared minus 4 times what is going to be negative 4? What will it be? 1. Usually it's going to be a number like negative 1, positive 1, negative 2, positive 2, negative 3, positive 3. It won't be a big number. So I would always start with 1 or negative 1 and see if it works, guess and check. So 1 cubed is 1 times a negative 1, so you get negative 1 plus 1 is 0, minus 4 is negative 4, yep.
You just plug in 1. You find a derivative first. Or you plug in x. Not that number x.
Next step. Find the derivative. The derivative of this guy is negative 3x squared plus 2x minus 4. Plug in the number you got from step 1. Negative 3. So we get 1, negative 3, minus 2, minus 4, which is, wait, did I do something wrong here? Oh, I forgot to, wait, no square root? Oh, why did I put negative 1? The answer is 1. Sorry. I don't know why I put negative 1. That's weird. It's supposed to be 1. I got 1, but then I wrote down negative 1. I don't know why. So that's going to be negative, positive, negative, what is that, negative 5? Flip it. Done. Okay.